So I guess it's time to start. First of all, welcome to the 5th seminar of this series of years. So today the speaker is Sanaz Nikghadam, and she will talk about computational creativity to design cyber-physical systems. So it's certainly a very exciting topic, and I think we are all tired of Zoom and these kind of sessions, but I hope that these very interesting topics will help us to also switch from the normal activities of every day and have some time and some opportunity to discuss new subjects that are very interesting. So after the presentation of Sanaz, there will be again a period of discussion, not only for questions and answers, but also for opportunity for you to express your opinions and so on. And that period will be moderated by Paula Loro. So thank you both for accepting the invitation. And so Sanaz, you can start.
Okay, thank you. I hope you are seeing my, I'm sorry, I believe I share it. You see my presentation? No?
No.
Okay,
Yes.
I believe you can see it now. Okay, good afternoon, everyone. First of all, I would like to thank Professor Camarinia for this interesting seminars. It's really an opportunity to learn about different subjects. I hope we continue this for the next years. It's very interesting. And as Professor Camarinia mentioned, today I would like to talk about computational creativity design cyber-physical systems. My name is Sanaz Nikghadam. I am a senior researcher in Uninova. I have a PhD in information technology management, and my specialty is in business intelligence. So I am not an engineer. My main research fields are computational creativity, business intelligence, right technology empowerment, and also technology assessment and acceptance. As I said, today I want to talk about computational creativity to design cyber-physical systems. That's why first I would like to a bit talk about creativity's concepts. Then I will introduce you computational creativity, and after that we will see the computational creativity concept in Industry 4.0. Then we will see how we can use computational creativity to design cyber-physical system and its relation with collaborative networks. And finally, I will finish with some points in this presentation. So let's start with a few questions from ourselves. Have you ever stood in a museum, gazed on a priceless painting and thought to yourself, I wish I could do that? Or maybe it was the last time you read a masterwork of literature and you wondered what it took that author to make such a timeless and impactful story. Or possibly your mind raced on hearing a classic piece of music with notes from piano curated by a genius. Okay, no doubt we all share a story of creative envy. And the good news is all of us, without exception, we all have a creative streak in ourselves. Being creative is more than just producing that clever new something. Creativity is a vitally important facet to human development. For example, creativity helps us to see a big picture. It motivates us. is help to solve our problems. Creativity can make us more productive. It can boost our confidence. It help clarifying our thoughts or feeling. It also can help us to express ourselves, exactly as Professor Camarino was mentioning. Maybe instead of questioning, we should express ourselves. Maybe you can be creative in this meeting. Or it can bring people together. Actually, this seminars is a creative thing, so it's bring people together as a creative act. And creativity releases stress, and even in some aspect, it can help us to live longer, and a lot of other things. But to understand creativity, it is important for us to go for the all element and competence that creativity has. So we should learn about creativity from different perspectives. Let's look at the creativity concept much deeper. I don't know, I'm not sure that I shared with you the sound.
How do you define creativity?
Yes.
What is the message here? How did they do that? Why did they do this? Why is this valuable? Is that more creative than this? For something so hard to define, there's an awful lot of creativity about. Songs, stories, buildings, books, pictures, products, ideas, looks. And that's not even the half of it. Since the year 2000, there have been over 1 million articles and books published on the subject of creativity. And the creative industries are now the UK economy's fastest growing sector. But what exactly is creativity? Albert Einstein said it's intelligence having fun. Donatella Versace thinks it comes from a conflict of ideas, while Professor Ruth Noller said it was C equals FA open bracket, yada, yada, yada.
So, what really is creativity? How really we can define creativity? Creativity is what happens when a person produces something that is novel, appropriate, generative, or influential. An idea should be definitely new and novel. For example, in art, we call something creative that we knew and nobody saw it similar of it before. But the question is being new and novel always enough? The answer is no. For example, if our problem is to find an answer for equation like 2 plus 2, and we give an answer like 10, it's just the wrong answer. It's not correct because it's a wrong answer and it's not a creative. So just being new cannot be always creative. Sometimes, and most of the times actually, it should be appropriate answer. For higher level of creativity, sometimes novelty and appropriateness is not enough. It should also be generative. What does it mean, generative? Generative is mean that this new and appropriate thing should lead us to produce more new and appropriate things. It could be, when I am saying more new and appropriate things, I am talking about products, ideas, solutions, and a lot of other things. But sometimes even being generative is not enough. It should be that novel, appropriate, and generative things should be also influential. What does it mean? It means that the creative thing should shape the way that people think about or doing things same as it in the future. So this is we call as a creativity. Well, Most of the time, people confuse creativity with innovation. Even in a lot of scientific documents, if you go especially in organizational subject management, you see people confuse these two terms, but they are completely different. We can differ creativity from innovation very, very simply. As we saw in the previous slide, creativity is the ability to develop new ideas and to discover new way of looking to the problem or sometimes opportunities. So we are not being creative just for problems. Sometimes we are being creative for opportunity that exists in the environment. While innovation is the ability to apply creative solution to those problems or opportunities in order to enhance people's life or enrich the society. So creativity is about thinking about new ideas, but innovation is about putting that new ideas in action. Here you can see differences between creativity, invention, and innovation. As you see, creativity is ability to create something new, and yes, that new thing should be appropriate, but invention is creating that new thing, and innovation is transferring that new idea into a useful application. So we are saying, I can do it, I do it, and I do it for good. So this is the steps. So creativity is a prerequisite of invention and innovation. Invention for us produce new knowledge, and innovation will bring us new products, new services, and new processes. For knowing better creativity and its process, psychologists developed several approaches to it. As you can see here, there are at least 5 important psychological approach or model to creativity, which are psychodynamic model, personality model, psychometric model, problem solving, and constraint models. The first 2 approach that I made it in red gave a very little credit to creative thinking. Based on, for example, psychodynamic model of creativity, creativity is something that's happening in our unconscious. So when you are sleeping, in your dreams, you are most creative person. Based on personality model of creativity, differences between people impact their creative ability. For example, neuroplasticity of brain of people can be completely different from each other. So it is impacting people, impacting their ability to respond to the environment. And according to the personality model of creativity, this will really impact on the level of creativity of people. Actually, based on these 2 first models, creativity is something that is not controlled. You cannot control this ability, this skills, or this capacity. But in the other 3 approach that I made it in blue, we can control creativity. We can develop our creative skills. We can solve our problem creatively, consciously. For example, in psychometric model of creativity, creativity is something that can be felt, and it's a matter of divergent thinking, which can be supported by brainstorming technique, and will be followed by a convergent thinking to produce a creative idea. Or in the case of problem-solving model of creativity, creativity involves finding novel solution to problem, and all research for the novel solution take a place in a space that we call it problem space, which consists of initial state, search space, and goal state. And creative problem solving is a gradual development from initial knowledge to a final goal state. And in the case of constraint model of creativity, creativity is actually an activity in the creative problem solving. Externally imposed and internally or self-imposed constraint can help us to reach a creative solution by narrowing the search space and guiding us toward the goal state. So we can see in these models, they are giving some ideas how we can replicate the process of creativity by ourselves. For example, for being creative, maybe we need to, first of all, define a variable or problem. And as much as we can, we should find associated information about our problem. Because based on the constraint models of creativity, constraints help us to narrowing our search space and also helping us to converging our ideas to an optimized idea. Or based on the problem-solving model, we need to define a problem space which contains some initial knowledge, some possible knowledge about the problem and components of solution, and also the information about the goal. Despite psychodynamic model, all other models agree that some personality features support creativity, such as persistence, self-confidence, independency. When a person has attraction a lot to complexity or having tolerance to the doubt, or people that are intuitive or they have a broad interest, or those people that are energetic, or those people that have enough drivers to achieve, who is loving their work, or who is taking a lot of risk. These people this kind of personality features can support creativity. At the same time, some personal and environmental barriers can reduce our creativity ability, such as when we have an extreme focus on external motivation, we are limiting our creativity. When our supervisor sets some limits for us, when we are facing critical evaluation, when we have a close and controlled supervision, or when we are facing a competition in a win or lose situation, when we are control or decision-making process, or when accessing to the information we control, or people that are blindly following the rules without critical thinking about those rules, or people that are trying to be always practical, or people that are becoming so specialized. Or, for example, in my case, a person that's always scared to look foolish, or fear from doing mistake and have a failure. All of these show human, again, have some limitation regarding to the ability of creativity. Maybe that's why, as same as all other ability, skills and tasks that we try to give them to the machine, scientists work to develop machines that simulate human creativity, or create machines that be creative on themselves, which called computational creativity. Now, let's see what is computational creativity. Computational creativity, as you see in this picture, is an effort that is located in the intersections of a multidisciplinary field of artificial intelligence, cognitive psychology, philosophy, and art. I will not define each of these fields, but just for unifying our thoughts. When I am talking about AI, actually I am mentioning to the ability of a computer program or a machine to think and learn. When we are talking about cognitive psychology, we are mentioning scientific study of mental process such as thinking, such as problem solving, such as language. Or when we are talking about philosophy, we are targeting a way of thinking about the world, the universe, the society. We want to know about the nature of anything, including human. And when we are talking about art, we are thinking about the expression or application of human creative skills and imagination. A good question can raise here that what is the differences between computational creativity and artificial intelligence? Actually, computational creativity is a sub-branch of artificial intelligence, but let's be honest, if you ask most of AI scientists, which some of them are here, for example, Dr. Ricardo Perez, they will not find their final output as a creative output. I'm not talking about the process of creating that output. I am just talking about the output. The process of reaching to that output, for example, can be creative. You can produce a lot of creative algorithm to reach that output, but the output can be not creative. Now, let's, based on this knowledge, redefine the computational creativity as the use of machine, include AI-based machines to emulate, to study, to stimulate and enhance human creativity. It involves some experimentation with the goal of finding innovative idea and thought process in the fields like art, literature, architecture, even cuisine, and also definitely engineering, music, and any other field that you can think about. Let's summarize goals of computational creativity. As I said, the goal of computational creativity is model, simulate, or replicate creativity using a computer to achieve one of these several goals. First of all, to better understand human creativity and to formulate an algorithmic perspective to creative behavior in humans. Second, to construct a program or computer that is capable of human-level creativity. And third, to design a program that can enhance human creativity without necessarily being that person creative. My own PhD research were targeting the first and third goals. In my research work, I try to understand better human creativity from neurological perspective to organize computers in a way that could control our creativity level unconsciously, actually. The reality is we cannot achieve to computational creativity without a clear understanding of human creativity. And we talked before in previous slides about most important cognitive models of creativity developed by psychologists and behavioral scientists like psychodynamic model, personality model, psychometric problem solving, and constraint models. But psychologists and AI scientists such as Margaret Button, who I call her the queen of computational creativity, also developed creative idea generation process model. For example, according to the Margaret Button 2004, there are 3 different creative idea generation processes that is include combination, exploration, and transformation process. In combination process, we combine familiar ideas to produce unfamiliar combination. Exploration process is talking about generating novel and new ideas by exploration of a structured conceptual space. And transformation process is about transforming one or more dimension of the conceptual space. So the style that is exists, we are changing some of the dimensions. I will talk about these three processes in the next slides more. As I mentioned before, in combinational creativity, by connecting ideas together, by connecting subjects together, we can have creative leaps, which can produce something that can be considered as one of the biggest things that human done in their story. For example, poetic imagery and figurative language are examples of the combinational creativity. Or Cartesian geometry is the result of combination of geometry and algebra. Also, if you check in the history, you will see that the Ford Motor Company did not invent assembly line. They even didn't invent interchangeable parts or even the automobile by itself. They combined all of these elements in 1908 to produce the first mass market car that's called Model T, and it's a very beautiful car actually. In exploratory creativity, we move through a conceptual space and try to explore what is there. When we know better about the conceptual space, we can make novel and appropriate combination with the elements that exist inside and outside of that conceptual space. Genres in music, art, movies, and others can be a very good example of conceptual space. Most of the artists, good artists, I'm not talking about any artist, spend their whole life exploring and mastering in this conceptual space, in these genres, and they try to produce wonderful results. In transformational creativity, we transform the conceptual space or a style by changing one or more of its defined dimension. So by changing the conceptual space, we have a new conceptual space which we can generate new ideas in it. These new ideas could not be made in the previous conceptual space. How much the dimension that we are changing be more fundamental, that transformation will be much more powerful. So the idea that we are producing in this new generated space will be much more novel and unique. For example, non-Euclidean geometry is a result of transformation in a fundamental dimensions of Euclidean geometry. So all rules, problems, and solution in this new geometry, completely new and compared with the Euclidean geometry. Or Cubist approach of Pablo Picasso is also a result from transformational creativity. Now let's see which type of creativity process is much feasible for machine. Maybe we think that reaching to the combinational creativity for machine be much more easier in compare with other process, but this is completely wrong. Actually, it is the hardest process for machine, while it is the easiest process for human. And why? Because human has a very rich store of world knowledge, include cultural knowledge, which impacting a lot in our creativity. We do not need to learn how to associate things together, because it is a natural feature of our associative memory. We have also enough perspective and criteria to evaluate ideas and modify them. But in the machine, there is a huge lack of access to the richer store of knowledge, especially the cultural knowledge. There is a lack of an associate memory and search process, and has a lack of evaluation criteria. We should know that generating new combination actually is not hard for machine. But the question is, how many of these random combinations are really valuable for us? So this is the part that is hard really for machine. But what about exploratory creativity? Actually, AI can model the exploratory creativity by enough clarifying the rules of relevant thinking style for putting them into an artificial intelligence program. How much we find better rules in that conceptual space that we are concerning about, and putting them in an AI program, we can have better exploratory creativity program. For modeling exploratory creativity, in addition to AI skills, we need to know deeply about the conceptual space that we are concerning. For example, if it is art, if it is, for example, religion, if it is, I don't know, literature, anything. We should deeply know about that concept. When we know about, when we better know about that conceptual space, we can get better decision to have deal with the different components and relation between conceptual, that relation between conceptual component in the conceptual space. In some exploratory models, machine actually produce results that can even be compared with even a professional human. Eurisco, Bacon, Aaron are some of AI programs that use exploratory creativity. Eurisco program is a transformational system. It's also an exploratory process that can be applied to a wide range of domains. Bacon program is based on exploratory AI creativity and design for model scientific discovery. And Aaron program is also exploratory based AI creativity, which is exploring line drawing in a particular style and coloring. Let's look at to the Aaron. As I said, Aaron is an autonomous entity capable of generating original artwork. For example, in the picture that you see in the left side of this slide, let me also put this video to work. The picture of number 2, 4, and 5 made by Aaron, while the picture number 1 made by human. And finally, picture number 3 is a collaborative work between human and machine. In Cohen 1982 article entitled How to Make a Drawing, and 1994 article entitled The Further Exploits of Aaron Painter, he described how machine could use exploratory creativity and machine learning to develop machine in a way that could produce original artwork. Actually, Aaron was a computer program that was learning how to draw, and Cohen taught Aaron everything from scratch, including how human hand move on the paper when they are drawing. This machine, this computer, did not have any visual system at all, but it has something that human being does not have it, and it is absolutely impeccable memory to build an internal model of the colors. As a human, we do not have color imagination. For example, if I cannot tell you, for example, I want a particular color to put in my wall, and for making this particular color, you should put 3 parts of this color, 2 parts of that color, and a bit part of this color. We cannot build an image in our mind for the color, but machine can make that image very perfectly and very well. Okay, this video is not finishing. And finally, transformational creativity. This is my favorite model, actually. Some people believe this process of creativity cannot be simulated in the computer because this process is not just producing new and significant ideas, it's also about producing new way of thinking based on the new generated rules. But okay, Margaret Budden, that I mentioned her before, believed that the rule in the program determine its possible performance. Okay, I believe any computer engineer right now here agreeing with her, because this is exactly how a computer engineer look at the programming. So for having a transformational creativity, the program must include rules that change itself. One of the algorithms that can do this is a genetic algorithm, which can change in the program's own task-oriented rules. However, while it is possible to simulate transformational creativity in machine, it will be very difficult because human associate memory and human values are difficult to express in computational form. And when a conceptual space is transformed in terms of computational system, the result may not be interesting for the human based on the values that human has. That's why current attempts in AI models of creativity are mostly in the exploitation, not in the transformation. Here I have card SIMS genetic image. This genetic image is one of those programs that use genetic algorithm to generate visual image. Card design an interactive platform between human and machine. He put 16 monitors, as you see in the pictures, that were showing image to the audience. In front of each monitor, there was a sensor. The image that is much more interesting and chosen by the audience was becoming the parents of the next generation of image. So this is one of those transformational creativity that we were talking. Or much recently, Deep Dream is a computer vision program presented by Google, uses the convolutional neural network to enhance image and therefore creating a dreamy art, which can be qualified as a unique and authentic work. This program generates a unique style of visual image that cannot be made by human. When we upload an image in Deep Dream as a guide image. The algorithm reconstructs the guide image in the layers after layers through a neural network that is designed to categorize all sorts of different objects like man-made structure or animals or anything else. Google called this process inceptionism, which is referring to a science fiction movie named Inception, where the dreams are structured in limitless layers. So the name is coming, the name of this process coming from a movie. This program, by recognizing the guide image and emulating it based on its neural network, created a different layer each time. How much this program goes to the higher level, it will identify more complex feature on the picture and create more complex image by itself. It may be interesting for you that right now the RIX group of Uninova is doing to tech art or art tech, I don't know which is mostly more correct, for Colombo Shopping Center and Madeira City, which is kind of transformational and exploratory AI creativity project. The teams that are working on this project are included Professor Barat, Dr. Jaspi, Dr. Peresh, and our artist Alireza, and myself. And here you can see a classification of different type of creativity models that we already discussed. The cognitive models of creativity are those models developed by psychologists and behavioral scientists that explain how the creativity is processed in the brain, while AI computer models are those developed by computer scientists to support the implementation of creative-based computer tools. Okay, here you can see different computational creativity application. For example, we can see computational creativity in a story, language, design, coding, game, logic, image, math, and science, and a lot of other things. So let's see how computational creativity play in the market of Industry 4.0. We know that today, in a connected environment of data, people, processes, services, system, and IoT-enabled industries assets, industries are transforming, and this information-intensive transformation, we call it Industry 4.0. And according to a survey in the 19 countries, 87% of business leaders believe that Industry 4.0 will lead us to more economic equality and stability. In this revolution, most valuable skills across different fields is expected to generate around $1.1 billion in 2026. While in 2018, global computational creativity market was just around $205 million. It means this market compound annual growth rate will be around 26 or 27% between 2019 to 2026. And if you ask which factors make this market grow, we can say increasing automation of creative skills or creative tasks and adaptation of computational creativity solution to improve the creative process. And based on application, the computational creativity market mostly will shine in the marketing and web designing, product designing, music composition, photography, videography, and video gaming development, automated story generation, and other fields like training, simulation, and R&D. And actually, the marketing and web design are those applications that is expected to grow at the highest rate. In Industry 4.0's environment, how much the complexity of industrial environment increases, the demand for designing better industrial systems also will increase. Industrial system cannot be designed actually right now based on those fancy ICT solution, and we should change our approach in designing this system. For example, seeing this system as a collaborative network of machinery, people, given product, and using all of our technical framework with giving importance to computational creativity for generative creative solution maybe help us in the process of designing the new complex systems in this environment. We need higher level of creativity and innovation in collaboration, in design, in composition of cyber-physical building blocks of Industry 4.0 to help this revolution really work. That's why understanding better human creativity concept and human creativity in cyber-physical system is very important. We should not forget that collaboration has always functioned as a kernel of creative work. But it seems that in the future of industry and digital transformation, without creative collaboration and creative collaborative network, we will not have a good future. That's why in a research work that we've done, we wanted to motivate a discussion about the application of computational creativity to design cyber-physical production system. Our argument in this research work was that the fourth industrial revolution leads industries to be smarter, more flexible, more integrated, with a higher sustainability and using better the available resource in environment. That's why in close future, manufacturing a cyber-physical system as the core, as the heart, at the core of Industry 4.0 and collaborative network should enable the communication and collaboration between human and machines and products. So there is a triangle of human, machine, and products that we should target. So new smart cyber-physical system can drive innovation and competition in different sectors like agriculture, energy, transport, and other sectors. And SMEs, particularly startups in ICT sector, are the key participant in the development of the innovation and value creation potential of cyber-physical system. Considering that a cyber-physical system involve transdisciplinary approach, merging theories of, for example, cybernetic, mechatronic, collaboration, design and process science, creative computation. It might be crucial in the design of cyber-physical production system to reduce our dependency to human creativity. This type of cyber-physical systems, which are based on creative computation, can support different things. It can support agile creative production to increase customer satisfaction and improve extensive integration between customer, companies, suppliers, and above all, sustainably creative economy. We can say that computational creativity-based cyber-physical systems support, generate, and evaluate creative solution in Industry 4.0 environment. So here you can see how we can use computational creativity to design a simple, really simple assembly production system. This assembly production system assumed to assemble an adhesive tape ruler dispenser. This adhesive tape ruler dispenser has 4 parts. Part 1, part 3 are joining together with a part 2, which is the tape roller, and the part 4, which is a screw. The assembly operations happen on the top of a workpiece carrier, which is are transported by a conveyor. Our assembly production system module include a vertical and horizontal moving axis and a bulk feeder for screws. Each module of this system has a digital twin, which is following the RAMI 4.0, so we can consider module from different suppliers, which can be considered as a candidate for creating different possible layouts to answer the customer problem or customer order. In this figure that you can see how the 2 robot accesses Z and X are combined together with a gripper to make a 2-axis pick and place robot. This created pick and place unit is used to execute all of the required assembly operation for the tape ruler dispenser. But where is the computational creativity and where it happens? Computational creativity design tool can generate many new and significant layouts for making such a dispenser, and choose the one of the layouts that is best answering the end user defined constraint. When I am talking about the word, I try to use the word that we defined in the creativity and computational creativity. And that's why I'm saying end user defined constraint and available measures. For example, the cycle that this circular layout can be considered for producing or tape ruler dispenser. All robots in this layout have identical topology. The loop is in this layout make this assembly production system more flexible and adaptable. Anytime workpiece carrier is visiting the robot, one is allowed to execute 2 different tasks. Robot 1 is, in this specific case, work faster than Robot 2 and Robot 4, so assembles part 1 as well as part 3. Empty workpiece carrier are considered as an input in the that you can see in the in point, and out point show the point that where finished product leave the assembly production system. Letter A, B, C, D that you can see in the picture showing bulk feeder for all parts. The screw can be fed by any feeder type. And this was a very, very simple example layout of assembly production system that could be proposed by computational creativity-based design tool. This layout created by considering the final product which is in this case the tape ruler dispenser, and also considering the different module and producer constraints. The case we mentioned here is a typical manufacturing design problem that is represents one type of Industry 4.0's problem that could get benefit from application of computational creativity. In this type of problems, the goal is to autonomously and intelligently generate the best layout and configuration, and computational creativity can help us to reach our goal. Actually, computational creativity-based design tools can be a new generation tool of that can that are appropriate and applicable to develop cyber-physical systems in which collaboration between components are very important. In this research that I mentioned, for developing this new generation of computational creativity-based design tools, we proposed a possible building block. By proposing these building blocks, we would like to support the development and implementation of Industry 4.0 based cyber-physical system and collaborative task. In this building block, we can see objectives, also digital twin module, the knowledge management module, the basic operational module, the digital twin of component module, and the computational creativity module. In digital twin module, we have the digital twins of manufacturing components that can be candidates for the possible generated layouts. The most important characteristic to be considered here is a description of operating parameter and their functionality or basic skills that are relevant to our problem. The objective in these building blocks are the products to be produced. For example, the adhesive tape ruler dispenser is the product that should be considered for designing or assembly production system, and or computational creativity-based design system should consider about it. The basic operation module include collaborative network module, user interface module, knowledge intelligence module, and supervision module. These modules orchestrate the functionality of the design tool and interacting with the all main components. The knowledge management module is responsible to manage and interact with the all different knowledge bases. We should know that knowledge bases are very, very fundamental in the computational creativity process and system. In computational creativity system, technical knowledge are fundamental, but common sense knowledge, which we can call it also word knowledge, is also an important player to implement the different creative approach. We include ontology in this module to indicate that concepts and their relation are fundamental. Technical and word knowledge bases are more related to rules or a set of rules that are important to creative process. Also, learning will be an important process to be included in the architecture to update the different knowledge bases. The computational creativity module will support the computational creativity process. The idea is to have 3 different modules, each one responsible for one of the creative process: combination, exploration, and transformation. Our intention was to create a modular system that can accommodate a stepwise approach in which the system can be enriched with modules or data with modules as they are being developed, when they are developed during their development. For example, if there be no available module to support transformational and combinational creativity, but exploratory module be available, then the system will only apply exploratory creativity. And in the end, let's conclude this session by mentioning 4 main points that led us to achieving computational creativity in different sectors, especially in designing cyber-physical systems. First of all, we need to structure the work about creativity. I mean, those works that are non-computational. It involves working with psychologists, behavioral scientists, cognitive scientists, artificial intelligence scientists, and neuroscientists to really understand what has been done until now and how it can be applied to the computer-based system. We also need to make a good review and a structure about all of the computational creativity work. For example, which computer models of creativity exist, where they have been applied, and how they can be used in our own domain. For example, if my domain is management, how it can be used, or which new modules are needed and in which new field of application in the cyber-physical production system computational creativity can be applied. As the third point, we believe that we should refine and work on a more elaborate architecture for the computational creativity-based design tools that we presented in this research. And finally, we should understand and explore how computational creativity can be used and applied to facilitate the collaboration in collaborative network. Thank you, everyone, for listening. And
thank you very much, Sanaz.
Thank you, Professor.
It was a great presentation. So we now have a period for discussion and for some questions. And Paulo Loro will be the moderator for this part of the session. So I would just ask everybody to turn your cameras on so that you could see who is talking and asking questions or making comments. And please feel free to participate. Paulo.
Yes, I'm here. Oh, I would like to thank Sanaz for her interesting presentation on computational creativity to design cyber-physical systems. And it was quite interesting to learn about these new things and the definition of the concepts on creativity and innovation. So the session now is open to questions. It seems that there is nobody yet for the questions.
Well, I can ask one. You should.
Okay.
Nobody
Okay.
questions. Sanaz, you mentioned in the certain point in your presentation, you try to relate computational creativity with the industry 4.0.
yeah.
So do you really mean industry 4.0 or do you mean industry 5.0? I'm not joking with words.
No, I understand. If you ask me, it is actually a wonderful question. I love your question. If you ask me, it's not really industry 4.0, but we don't have yet industry 4.0. Really, we have still, okay, we are moving into the industry 4.0. But if you ask me, computational creativity really can target something, a higher level economy, an economy that is coming like feeling economy, when something in future computational, but some of the parts, for example, we have right now in current thinking-based economy. I once look at like this. We are right now in the thinking-based economy. In some cultural and creative industries, not all industries, we can apply computational creativity. In some of aspects of some of cyber-physical systems, not all cyber-physical systems. It's not maybe visible right now for Industry 4.0 in all of the cyber-physical systems that we are thinking about, especially in automotive industry or things that we are mostly working in, at least in Uninova. But in some of the industries, like fashion industry, like art industry, when I'm saying really there is an art industry, or the cultural industries, we can right now in even Industry 4.0, we can use computational creativity. But if we cover all of industries, I believe it will not be anymore 4.0. It will be, at least it will be 4.1, not 4.0.
No, the point is that it's a matter of maturity. Yes. Of the techniques or the approaches, because what people are bringing into what is called Industry 4.0, most of it was in fact developed 30, 40 years ago in research. Yeah. So what we are suggesting is a line of research that can of course be applied to industry, can of course be applied to cyber-physical systems, but the point is, how long will it take, or do you expect it to take, before we have mature solutions that can be deployed in real world?
I give you an example. When I was working on my PhD thesis, that I started around 2012, and I finished around 2015, 16, my PhD thesis. It was when I was searching about computational creativity or digital creativity, anything, you can change this keyword, because in a lot of work they are using different keywords. There was a little, even in this case, there was a little literature in this area. But when I am right now looking at the literature, at least, it's growth very fast. It's working. People are working really in this area, are working, and the same time that scientists in the universities and research centers are working, the same time is an important target for the big businesses like Google, like Amazon, like big companies that are that they need such a technology. That's why they are really investing on this, and I think it will really grow fast, and really the maturity process come fast, much faster than we expect. When you are seeing, for example, the deep dream of Google, it's really blowing the mind, but it exists. It's not. A few years ago, it was not such a thing. Even the knowledge was not exist, but now we can see that it's working even.
Okay, there is another question. José Barata.
Hi. So, Sanaz, I enjoy your presentation. Always were very nice slides and it was clear this part of the creativity. But I would like to continue what Professor Camarina was saying, and I believe that you should exploit it a bit more in the direction of, in fact, that we really need this a new way of thinking, because we are in research planning ahead. So, and I believe one aspect very important, and I would like some comments from you, is that, okay, we have this new way of creating, or the systems are not only about the technology. There is one thing that you mentioned. I believe it was feeling economy, but I'm not sure because there was in a place with bad internet. But and there is another aspect that is, up to now we are talking about creativity, but don't you think that in the end, because this feeling economy is very important, the human beings in the factories, the quality of life. So we need the people and machines. We don't want just machines. And then there is this thing that I would call it collaborative creativity, in the sense that could be used for both the design and the interaction and solving the problems. So I would love to have some comments on that.
2 weeks ago when Philippa was presenting, I was here excited. Really, I tell you, it was very wonderful presentation because I love the effective computation. Okay. And when she was mentioning all of those knowledge, and I was thinking, okay, I want to work with her. I want to any project she has, she involved me, and I want to involve her in one of the projects that we are right now having in AAL, which we call it Life Plus Plus for elderly people. It's correct. Anything we do, anything scientists does, is about improving people's life. For example, I'm not saying that computers should come and get the creativity out of human. I am saying some of it can help us. In some aspect, for example, in designing something, it can give us ideas. It can enhance it. So computational creativity is not just making a machine to be creative, as I defined it. It's also about understanding about human creativity. What is it? And how we can reach to this and how we can control it better. It's also about making machines that help us to be more creative in designing, in different things. So it will help us to do our task in different aspects. If it is creative task, if it is a cultural task, even if it is emotional task, to be a more powerful person, to do it better and to do it easier, not just, and even learning it easier. Some of these machines, for example, what we are trying to do in Life Plus Plus for the people that is over 65 years old and can face dementia, we are trying to develop some effective computing and some creative computational creativity measures or tools to help people to slow down their dementia progress. So it is improving their life and it can help them also to increase the life quality, the current life quality, not just stopping their dementia, is also the current life quality by, for example, changing for example, we are putting gamification in this project. We are trying to change every day the different type of games. And is it a person should every day change the components of the game? It will be hard based on the people. If the number of the user and be a lot, and we have different possibility, we need the different possibility. This will be hard to ask a lot of people to give the idea how we can make a combinations. So we will ask a machine to do this for us based on the criteria that we are giving, based on the approach that we want. So it's helping us, not really we don't want to give everything to the machine. We want to get help from machine. This is at least my opinion.
I can say something here as well that is related, and Camarinha will remember that, because I really think I want to connect this reality of creativity, humans, technology that are important. And in my opinion, because of the things that we have now, the technology that we have, is even makes more sense one conference that Camarinha created, let's say 5 years ago, but you have to multiply by something, okay? That was called balanced automation. And in fact, it is really something that I see, and I really want you to consider this aspect of this collaboration, in the sense that is not just operation, but in having new creativity in the way that you are producing. And I'm happy that when you mentioned all these aspects about the presentation of Felipe last week, that for me was also very interesting, and also and the possible interactions in the shop floor, but also in things like AAL, and this involves also Professor Camarinha, as I have told you. So this can be something important for your work, because it's one aspect. The other aspect is all the work that needs to be done, a new perspective. Another aspect, in my view, is all this algorithms of AI that we were discussing with Ricardo Pérez and all these, that can be applied directly in this to create different types of things that you were mentioning. But it is also important to interact with these people. And why not even our robots or our machines helping the architects creating better houses? Why not?
Sure.
Better ships. Yeah. So it is. I am provoking someone here, but anyway, so it's like this.
Okay, thank you. Oh, another question, Luis Estrada.
I don't have your voice.
We are not listening.
Is it better?
Okay.
Okay, so I was telling that it was very interesting. I mean, always when I hear like talks or papers in which they relate creativity or some type of human cognition to what is artificial intelligence, I am always interested to know, especially what people think. So I just would like to read something. Actually, I was reading something related to deep learning and some criticism it has. So if you don't mind, Dr. Sanaz, I would like to read it. So it says, deep learning is not the result of automated machines creating by themselves such algorithms and after it evaluating them as well as the results. Deep learning is designed by humans who select the data, evaluate the results, and decide the next step into the change of possible actions. At the epistemic level, the decision about how to implement the validity of deep learning results is under the human evaluation. So considering this criticism against deep learning and the fact that a lot of these deep learning algorithms and neural networks are used to, for example, create art or creative new types of arts based on images, what do you think right now? Are we actually having this kind of creativity or intelligence to the extent that we can relate to the human level, how it is nowadays? Because sometimes I feel the creativity or the cognition of these algorithms are more like data, some numeric data that at the end, well, is the results of human intervention or human algorithms. I would like to know your opinion about this. Thank you very much.
Thank you very much, Luis. It's an interesting question, and I will answer it by going back to my slide that I was mentioning about 3 types of creativity: combination, exploratory, and transformation. What you mentioned about this criticize is much more considering the first two, is combination and exploratory creativity. We cannot say it's not creativity. When you are really knowing about different combination, how you make this association between things. Actually, human brain also doing the same thing. When you are making a new thing, but appropriate, you did a creative thing. If the machine make a new thing, which is appropriate, it means the outcome be new or novel and appropriate for solving the problem, is a creative act of machine, okay? For in the combinational and exploratory, when we are actually putting rules, the rules that we are giving to the machine. And the problem of these two, or especially the combinational, is that it's hard for us to define the values for the machine, how a combination can be valuable for us. So we still need to work on it. It's still a big gap of knowledge. But what is the criticize? This criticize can be answered if you have transformational creativity. That one of the algorithms that really can help us is genetic algorithm that can change the rule inside the program, the own task-oriented rule. So we will go for the if we reach to the transformational creativity that we already have in some part, in some program that I mentioned also in the slide. For example, you saw the car sims imagery, genetic imagery. We have right now, because the genetic algorithm changing the rules inside the program. But if you are saying all of the programs that call, oh, we are creative or producing creative ideas, I cannot say they are in the level that we are expecting and in the level that human does. No, we are still far from this and we need to work on it. So in this computational creativity, AI scientists should work with experts who really deeply know different areas. For example, in the case that I mentioned about Colombo shopping centers and or Madeira, that we are working on the tech art, we have AI scientist, Ricardo Perez. And in the art, we have Ali Reza, he's an artist. So they deeply know these two aspects. So we can bring these two knowledge together and having a computational creativity. But this really, what I, in the first point of my last points that I mentioned from those four, we really need to work together with all of the fields to have computational creativity. It's not just saying, okay, I can be an AI scientist, so I am going to be a computational creativity scientist. No, it will not happen. And a person that like me also, if I say I am alone just by understanding better human creativity in different aspects and different fields, am I complete enough to have to reach to the computational creativity science? No, I need AI science. Okay, so this is a multidisciplinary field, as I said.
Okay, thanks a lot. Thank you.
Okay, thank you. Oh, there's another question here. Shabna.
Thank you, Sanaz. It was a really interesting subject. Actually, the first time I heard about it, and I was searching a little bit. I raised my hand at the beginning, and then I regret because I said that maybe it's not so related to your work, but anyway, I will say it. Do you think that, actually I searched about it, I guess it's a little broad, but do you think that social computing is applicable in the creative computing? Because human cognitive behavior or creativity is connected to the environment inceptions and also experience inceptions. That's mostly related to the social experiences. And
your voice sometimes is cutting for me, but I try to.
sorry, maybe it's my
Please.
It's something that is not understandable. I will repeat myself. I mean that the social experience, it's really effects or related to the effects and has some causes of the individual person perception and creativity. So I couldn't find based off the now surgery that social computing has any place in this science or?
Yes, definitely. If you remember in my presentation, I was mentioning about word knowledge or cultural knowledge. It's not happening without the social aspect of us. We are a social animal, and we get our knowledge from society very easily. And this social knowledge, either for making a creative idea of solution, either for evaluating that idea and solution, is fundamental for both aspects, either creating, either evaluation. And if we have social computing to help us to achieve much more knowledge about the society, about the people, about their knowledge, that the hidden knowledge that they have, and a lot of other things, definitely it can support strongly the computational creativity. I can say if we develop in social computing, we definitely will develop also in creative computing or computational creativity.
Yeah, for example, now we have something like digital arts that are going to different zones, but actually this is something that is collaboration of human and kind of creative, I think, computing. They use some algorithms or some tools for creating that.
Even in the one that I mentioned about car synthesis, it was interactive between human and machine. So we can train our machines by interacting with the humans and even even interacting with the societies. If we could interact with the societies, definitely we will have much more knowledge for machine to develop themselves and put better rules, define better way to define the algorithm, how the algorithm will work. All of this can be really important for
and
the computer.
Something related to ethical part. If a computer goes to copy some kind of the art that human already made, is it any regulation for that?
Right now, no.
No.
No. If you are asking, no. Like a lot of other emergent fields that right now we don't have really ethical definition, like affective computing. We don't have really ethical regulation for that, because still this is a new baby. It's not. It does not have a good structure yet. We are still learning how we want. Still, we are defined. Still, I want to say we are in the level of concept. Okay. When I am saying, okay, there is some movement, there is some works, but still concept needed to be defined better and better. Anytime, even myself, I am working on this, learning. Anytime, even right now when I am reading my own PhD thesis, I say, wow, a lot of knowledge there is old, and my thesis is not really old. And if you see, until the day that I submitted for the Viva, I have the work of that year. So, but the speed of the works that are becoming better. That's why even in our work, we suggested that this architecture should improve, because it's not enough. It's the first a first idea, then it can improve. This is in a conceptual space, the conceptual level, like affective computing, like social computing. These are growing right now, and that's why we predict that future economy is not anymore thinking economy, it will be feeling economy. Why? Because thinking economy means a lot of thinking stuff that we are right now doing by ourselves, we are giving to the machine to do for us. And then we should take care of as a human about our feeling. It is what we will see in the future.
Hopefully. Thank you.
Okay, thank you. It seems that there are no more questions. I would just ask Sanaz, what are the fields where do you think that computational creativity will have higher impact?
In application, as I mentioned, even in my presentation, in marketing, in the business will have a huge impact. Honestly, even if right now it's not happening, I can say in all fields. Will one day will come, but in next years, as I mentioned, until 2026, you can see in marketing, in product design, in game development. These will be the fields that really computational creativity will work.
Okay, thank you.
Thank you.
So it seems that there are no more questions.
Anyway, I think we'll, at the end of the time, we should keep this time limit in every session. So I suggest that you finish here.
Okay.
So thank you very much,
thank you,
Sanaz, for
everyone.
a great contribution. Thank you, Paulo, for helping in this part, and thank you all of you for attending, participating. I just want to remind you that in 2 weeks from now, we'll have the next seminar that will be presented by Luis Gomes, and the topic will be about automatic generation of embedded controllers. So you are all welcome to the session on 26th of May at 5 o'clock. Yeah. So thank you and bye.
Thank you.
Thank you.
Thank you. Bye.
Thank you.